Hey there! Today I would like to show you one of my favorite projects. This is a Delta Kinematics based pen plotter which I've built and made a program to operate it. It also has an automatic tool changer and a really cool bolt-on driven Z-axis. First I'll show you how it was put together and then I'll demonstrate all of its features while making also some cool drawings. Enjoy! Here, the machine will make a simple demo to show the basic functions. First, we pick up the pen, make first part of the pattern. Then, the pen is dropped back off into the magazine before the second pattern is started with the red pen. This is a good example of the nice alignment that can be achieved with this magnetic tool changer. Once done, the tool holder head is lifted and then the carriages return to their homing position. A nice benefit of using a delta-based motion system is that the moving parts are really light. This means that everything can move around super quickly and the drawings are made in really short amount of time. To help further reduce the weight, I've also designed a Bowden-based pen lifting mechanism so that the actuator that is lifting the pen doesn't have to be dragged around on the pen carriage. Instead, it is installed stationary and the string and the cam mechanism helps to transfer the lifting motion. In this setup, the position of a pen is actually dependent on both the right and left carriages. To draw a horizontal line is very easy. Both of the carriages just need to move forward at the same speed. However, to be able to draw a vertical line, it requires the coordination of both axes in a little bit more complicated manner. Luckily, once we can figure out how to make a vertical line, we can just add that with a horizontal line and pretty much figure out all of the motions. This is the simplified model of the plotter, with the rails on the left and right, and the point of the triangle indicating the tip of the pen. With some trigonometry, it is possible to figure out what offset you need between the two carriages. This can be implemented in the control software, and then traditional 90 degrees XYZ coordinate system can be transformed into this delta motion system. The only remaining problem is that in this motion setup, actually connecting 2 points, you won't get a straight line, but an arc. So to solve that, we need to cut long lines into smaller segments. In the following demonstration, we can see how as we decrease the length of each segment, we get closer and closer to a true vertical line. This is the program that I wrote to control the machine. It works in a layer-based approach where you can browse in different input images for each layer. Once done, there's a few parameters that need to be set up for each layer, including way of processing. More on these later. There's also some general parameters like pen number, speed, and so on. In this demo, I'm generating the print of Istvan Orosz, which is called the snail. Big shout out to him for letting me use his art. Once everything is set up, we generate the preview, and then the project is saved into an XML file. From here, the project can be edited later. The other output is an NC file. This includes all the coordinates that the machine needs to go to, the speeds, and some other special commands. This NC file is then loaded into an NC file sender program, where we can have a final visualization and check of the two paths. The visualization is a little bit skewed because the program doesn't understand that this is a data kinematics-based plotter. Before continuing, GSender needs to connect to the plotter. and then the drawing can be initiated. It is also possible to keep track of the current progress of the drawing in GSender. The machine is taking the pen needed for the first layer. After taking the pen, the machine executes a simple contour, which will create the snail and the Fibonacci pattern. You may notice that the machine is completing the contours in a bit of a random order. This is because the contours are ordered to be completed from bottom towards the top. A much better approach would be to find the fastest route between all of them. This is very similar to the traveling salesman problem, and I might add this as an optimization later. The second layer is done with the same pen, but this time it's not a contour, but an amplitude modulation fill. This is to create a nice effect for the shadow of the snail. I designed this machine to use paper rolls, so it's very easy to get started with the next drawing when you're done. As mentioned before, there are multiple ways to process an input image. The most simple one is to draw a contour that can be read out from the image. When drawing a contour, the path generation takes the input image, and based on a threshold value, it finds the boundary between the dark and light area. The threshold basically decides what is the darkest shade of gray that is still considered light. When using purely black and white images, the exact value doesn't matter so much. While creating contours is powerful, sometimes it is needed that a patch of color is filled in more densely. There are multiple ways to do that. The first one is offset fill. Offset fill finds the contours of an image and offsets these inwards multiple times as long as it's possible. The density of the fill lines can be controlled from the path generation program. When there are holes in the input image, the offset fill starts to fill out the space from two directions, meeting in the middle. When the offsets from the outside and the holes meet, the remaining area is treated as a new contour, progressively filled in further. To break down how this octopus image was generated, I'm showing each layer with their input images, path generation modes, and output lines. The input images are simple PNG files that are usually created together with a layer-based photo editing software, and then the layers are exported separately. Another way to fill in a solid patch of color is by using lawnmower fill. It is a fill technique that uses straight lines to move back and forth between the boundaries of a contour, a little bit similar to how someone is mowing their lawn in their garden, covering every spot by moving in a zigzag pattern. For this path generation mode, we can set the density of the lines as well as their angle. Like demonstrated with this steam locomotive image, some really cool patterns can be created by stacking multiple of these fill patterns. AM stands for amplitude modulation. This fill technique samples lines across the input image and measures the brightness at each sample point. Then, a sine wave shape is generated and the height of each wave is scaled with the sampled value at the specific point. As an example, completely white input image will result in simple straight lines across the paper, as all the wave amplitudes will be scaled down to 0. When you consider a black portion of an image, here the wave amplitudes will be scaled to the given maximum, creating a shaded effect. This processing technique is different from the others shown before, as it creates a fill pattern for the entire canvas. There is also an option to only create an AM fill pattern inside the contour. To create an amplitude modulation fill inside the contour, a full image amplitude modulation fill is created, and then it is cropped using the contours of the image. To set up an AM fill layer, the scan density, scan angles, and max amplitude needs to be set, as well as the sampling frequency. The plotter can automatically choose from 7 different pens. Now I use the same kind of pens with different colors. However, in the future I would like to try out mixing in some different pens or markers. Pens are fitted into pen adapters that help with tool changing. In the path generation software, each layer is assigned a pen number, which indicates where to take the appropriate pen from. Pens are stored on a shelf-like magazine, and they are picked up and dropped off purely mechanically without any extra electronics. This is possible because of a magnetic coupling which is strong enough to hold the pens steady even during rapid drawing movements, but weak enough to be overcome by the stepper motors when the pens need to be separated from the pen holder. As seen in the slow-mo footage, during the pen pickup, the pen holder is moved towards the selected pen in a lifted position. When close enough, the magnetic attraction lifts and secures the pen to the holder. During pen drop-off, the pen holder, together with the pen, moves towards the magazine in a lowered position. As the pen is approaching its parking position, the pen holder captures the magazine with a snap feature. Now when the holder moves back, the pen is held by the magazine and the magnetic connection between the pen holder and the pen can be broken. The layer-based workflow of the path generation software creates many interesting possibilities for overlaying and combining different effects. In this example, multiple AM layers with different colors are mixed to get a nice look. As a demonstration of the plotter's capabilities, I recreated the painting called The Grand Parade from Fernand Léger. It uses many of the techniques shown before to create a new interpretation of the painting, starting with a black contour, and later the blocks of color are added with lawnmower fill. So, thanks so much for checking out my project. It's been a lot of fun working on it, and I'd love to have a discussion about it if you have any questions or comments. Other than that, have a great day.